guys, I used this circuit in my previous video for making a 500 watts inverter. So I'm going to remove all these transistors but reuse this heatsink. Hi guys, welcome back to my channel, and in this video I will be teaching you how to make a highly efficient but really simple 200 watt inverter. Now there are two reasons why I am actually making this video. The first and the most important one is that I took a vote from you guys for the type of video content you people prefer, and around 50% of the votes were in favor of videos related to inverters and circuits at the first place. The second reason is that you people really liked my previous 500 watts inverter video, which was my original design of a half cycle 500 watts inverter. Now what comes next is the making of the circuit for these two heat sinks, and the two circuits are going to be exactly identical. So the first heat sink and second heat sink are going to require two transistors CTC1351, one is here, second is here, and four transistors of 13009. Okay, so two for this and two for this. So this makes your one set of three transistors, and this makes your second set of three transistors, and these two CTC1351 will be used afterwards. Okay, so let's finish this part first. Okay, so first I'm going to place 13009 transistors. Okay, you can see 13009 MJE. Okay, so guys, the first set is ready. These two transistors together are MJE13009, as you can see, and this one, the separate one, is CTC1351. Okay, so this is the first set. Now the second one will be completely identical to this one. Okay, so guys, now that the two sets have been created, now I will mount them on a wooden base to keep them electrically isolated, which is very important for better output from the inverter. So what I have done here guys is I have connected these two transistors in parallel. The extreme left one is the base and this one is also the base. So the base is connected to the base. Middle one is the collector. Collector is connected to the collector, and the terminal to the extreme right is the emitter, and both the emitters have been connected together. Same as with this one, with this set. Okay.
Next level. Next level.
Okay, so guys, these two transistors are MJE13009 and this one is CTC1351. So I have connected the collector terminal of CTC1351 to the collector terminal of MJE13009, and I have connected the emitter terminal of CTC1351 to the common base terminal of MJE13009. So guys, these two wires were the emitters for this set and this set, so I have connected them together because this is the common emitter point, and these two white wires are connected to the collectors of both the sets, collector from this and collector from these two transistors. Okay, I will show you. Like this middle terminal is the collector. Okay, I don't know if you can see, this one is collector, right? Collector for this, and it is connected to the collector of this. So the collector of both the transistors, and same as this case, are connected to this, and the collector of this and this are connected to this wire and coming out here. Okay, so guys, this was the main transistor switching circuit which is going to feed the transformer, and it has been completed. Now comes the oscillation part. So guys, for the oscillation circuit we are going to need two of everything. The first is the power transistor CTC1351, 2 pieces. Second is 1 kilo ohm resistor, 2 of these, and IR receivers, 2 IR emitters, 2 pieces, 2 nuts, 2 bolts, 2 inductors, and these 2 plastic covers for the emitters and receivers. Okay, preferably black, or if you don't have black, then you should cover it up with a black tape. Well, the truth is I couldn't get the proper ones, so I used a plastic pipe and cut it of an adequate size, and then I covered it with black tape, and it works fine. I've tried it before. Okay.
Next level.
So guys, before I proceed any further, I think I should explain you what is happening. So this is the oscillation circuit. These two are the transistors CTC1351. Now what I have done is I have connected the base of this transistor to the collector of this transistor with the resistor 1 kilo ohm in between. You see the middle one is collector and the first terminal is the base. So first terminal is connected to the middle terminal of the other transistor with the resistor 1 kilo ohm in between, and same as with this one, the base of this transistor is connected to the middle collector terminal of this transistor with 1 kilo ohm resistor in between. The rightmost terminals of both the transistors, this and this, which are the emitter terminals, have been shorted together. They are connected together with this single wire, okay, and two terminals have been taken out finally from both the collectors. This collector, the middle terminal, feeds this end point of this inductor, and this middle terminal, a wire from this, feeds this terminal of the other inductor. Now the left out terminals from both the inductors have been shorted together and a common wire has been taken out. I will tell you later what it is going to be used for. And I have also connected this 1 kilo ohm resistor here. Okay, so all the resistors used here are 1 kilo ohm each, and these are the casings that contain the receiver and the IR emitter diodes here and here. Okay, so at present they haven't been electrically connected. Okay, so after doing the connections I will explain it further.
Next level. Next level.
So guys, now what I have done is I have connected the positive terminals from both the IR emitters, this one and this one, to the common positive point, the tapping point of the two inductors, which is the common positive point, with the 1 kilo ohm resistor in between. And to the negative terminal of the emitters, I have connected it to the other terminal of the inductor. Like the negative is this one, which is connected to this point of the inductor. The negative is this one, which is connected to this point of the inductor, while the positive terminals have been connected here with the resistor to this tapping point, which is the positive terminal, and positive supply will be given to this yellow wire. Okay, now all I have to do is connect these two terminals from both the receivers to the switching circuit, and the inverter should work. So guys, finally this is the transformer that I'm going to use for the inverter. Okay, now all I have to do is connect it to the circuit that I've just made. So guys, here as you can see, what I have done is I have connected this 100 watts bulb. You can see it is written 100 watts there. Okay, so I have connected this 100 watts bulb to this transformer, sorry. Okay, and to the input side, low voltage side of the transformer, I have connected this circuit. So these two white wires are the collector terminals that have been connected to the low voltage side of this transformer, and the oscillation circuit has been directly connected to this main switching circuit for automatic oscillation. And this is the 12 volts battery that I'm going to use to activate this circuit. Okay, so guys, now I'm going to connect the wires. The negative wire will be connected over here. Okay, yeah, the negative one is connected, and now I'm going to connect this wire. Okay, so guys, as you can see that it is working, it is lighting up the bulb easily. Okay, once again, yeah, I'll keep it like this so that it is visible a little bit better. Yeah, actually I think the battery is not very healthy. I restored it a few days back, so for that reason I don't think that the battery is performing really good, but this setup is working really fine.
Next level. Next level.
You see? Yeah. So guys, it's working pretty good. And there's one more thing. You see? Deactivating, right? Okay, so guys, that would be all about today's video. Thank you so much for watching it. Please hit like and don't forget to share and subscribe. And if you have any queries, you can always ask them in comments. Thank you.